In this lecture, we'll look at the RA representation of order by and also of set operations. First, let's talk a bit about order by. The relational algebra operator for order by is the symbol tau. But before we discuss it further, we should ask whether order by really belongs in relational algebra at all. So question one, to be mathematically exact, applying an ordering to a relation is meaningless. Why is that, given the mathematical definition of relations? And the answer is fairly straightforward. A relation is a set, and sets are not ordered. If we want to put a sequence on the elements of a relation, we need a different mathematical entity, something that's usually called a totally ordered set. And sometimes you'd call it a list in software-related discussions. And since this is a software-related discussion, we'll use list. So the tau operation returns a list. It's given a relation, but it returns a list. The other RA operators work on sets, not on lists, so tau is incompatible with them. There are two solutions to this. The simplest solution is to insist that tau be applied only as a final operation, with its result never used as the argument for further RA actions, except maybe a final projection. And this is consistent with typical use in SQL, where order by is more of a formatting instruction than an essential element of the query, and it occurs as the last action in the query, aside from selection. The more complex solution would be to extend RA to lists instead of just sets. We'd have all the RA operators work on lists and return lists, each with some rule for handling the order of the tuples. This might be done, for instance, to use RA notation for reasoning about query optimization and execution. Ordering of certain sub-results in the query can make execution of later operations, selects and joins in particular, more efficient. For this course, we'll take the simpler first route. But don't be surprised if a deeper study of RA for query optimization leads to the second alternative. So with that said, we can use the tau operator in this fashion. We give tau and a list of sorting key attributes operating on a relation to be sorted. The subscript attribute list has the same meaning that it does in an order by clause. It's a list of sorting keys from most to least important. So a statement like select ID first name, last name from person, order by last name, first name would be translated into tau of last name, first name on the result of the selection. And importantly, tau does not do any projection. It produces tuples with the same number of attributes as its argument relation, just in sorted order, even if it doesn't use all of them to do the sorting. So here's another quick example. We'll do select flavor and average price from product, group by flavor, blah, blah, and order by average price. And this in turn becomes, size that up a bit, do a group by with flavor and average price mapped to A price on product, select A price less than 10, and then a tau on A price. And again, there's no need for a projection since the gamma already did the needed projection. So question two. This stuff is a lot easier than the gamma operator, but just to be sure it's clear, please translate this SQL into relational algebra. And the answer there is, I'll size it up a little. We're going to do a line item join with product, and then we're going to do a gamma on that to do the group by. And then after that, we'll do a selection for price greater than 40, and that's a halving because it's outside of the gamma. And then finally, the tau operation to sort by receipt ID, or order by receipt ID. Now, RA also includes operators for the SQL set operations, or as a theorist would more correctly say, SQL implements via its set operators the RA operators union, intersection, and subtract, which respectively represent set union, intersection, and set difference. So the first example query from our earlier discussion of set operations, which did a union between two selects of different kinds of customer, would be written in RA as the union of two different RA expressions. The first one doing a select on customer per the first criterion and projecting to ID first name and last name, and then the second doing a different select and again projecting to ID first name and last name. And then finally question 3. Convert this query select purchase date from receipt except start date from sale, into relational algebra. And the answer here is going to be that we'll take the first query in RA form, purchase date on receipt, and do a subtract, thus a set difference, subtracting the start date of sales. So we'll get any dates that are purchase dates in receipts but are not start dates of sale. So we've now covered all of the basic RA operators and symbols. And we've briefly hinted at how RA might be used to analyze and optimize queries. In the next segment, we'll introduce RA expression trees and show how they can be used to transform queries into equivalent and perhaps more efficient other queries.